So MedBlocks is a project that I've been working on for about a week now. The problem it tries to solve is this. So when you go to the doctor and the doctor prescribes you something or has any data about you, that data doesn't actually belong to you. It belongs to the doctor, to the hospital, and they can do whatever they want with it. Now, I can say this firsthand because I'm a medical student in India, and I think things shouldn't be this way. We should have ownership of our data, and we should be able to transfer it among hospitals if needed. That's why I made MedBlocks. Now, this is not the first project which is trying to attempt this, of course. There are other projects, but I'll explain to you how MedBlocks is different. Now, in this article, I explained in detail what the problems are and how it can be addressed with new technologies like IPFS and the blockchain. And I'll just go over other projects that are doing the same thing, and we'll just see how different MedBlocks is. Now, the first one that I came across was Medical Chain. Medical Chain was just the typical kind of project you would expect when the blockchain space is booming with new money, and people just take any field of interest and then combine blockchain with it, and then they just get money. So Medical Chain looked like that kind of a project, and yeah, they have a token website. Like, why do you need a token for a medical blockchain? I mean, I don't get it. They don't have a working product. They have a team, they have a white paper, they conduct conferences. They don't have a working product, and they are launching an ICO. No, I mean, like, this could be called something else also. Like, this is just, yeah, this looks a little more direct. There are other projects too, like proof.work. Again, they have a good website, but they don't have a working product. And what came closest to a working product was MedRec by MIT Media Labs. And they are working on something very promising, actually. I took a look at their code base on GitHub, and what they are doing is they are storing user credentials on the Ethereum blockchain, and they are storing the data with the hospitals itself. And the way they can communicate among each other is through their own protocol, which they are calling the Guardian protocol. I read it somewhere here. Okay. Yeah, the database gatekeeper. So they have something called the database gatekeeper, which allows and disallows access to information from other hospitals according to the keys stored on the blockchain. So this was the most promising project in the field that I saw, and I have my own take on this same problem. So that's why I made this article, which explains in detail what the IPFS is. The IPFS is basically the interplanetary file system, and they are a protocol that is designed to replace HTTP. So basically, IPFS is designed in such a way that the content that you want is retrieved from the person nearest to you. So while MedRec is trying to implement this gatekeeper protocol among hospitals, why not just use IPFS? They are doing the exact same thing, and that's why I made MedBlocks. So MedBlocks uses IPFS and BigChain DB, which is kind of a blockchain database, to do the same thing in a much easier, more efficient way. So I'll show you a demonstration now. So now we are on the computer of a patient. So the first thing that we want to do is install MedBlocks. So we can do that by running, copy this URL and just run git clone that URL. So that will put it inside a folder called MedBlocks, which is here. Now let's cd into that directory. I like using bash for Windows because it's hard to install some things on Windows. So I'll just use bash. Just gonna install it using pip in the editable mode, and that should install MedBlocks. So let's just check the version. Actually, there is only one version, but yeah, let's clear all this and let's look at the help command, MedBlocks. Okay, now it has a lot of commands. The first thing that we want to do is register our patient on the blockchain. Alright, so the way we do that is right now I am inside the MedBlocks folder. This need not be the case. Actually, I will come out. I'll just come out here. And first, let's register the patient, right? Let's first create a user. Now what the create user command does is it generates a random key pair, both RSA and on BigchainDB for the patient. And it also asks for the mobile number so that it can register all those on the blockchain itself. So we'll be creating a user now. So it asks for the name of the patient. Let's say Siddharth. Phone number 994494. And it's giving a warning so that we save the file that it outputs right now. So I'm just gonna click. Yeah, okay. And it outputs a file called user.json. So now this file is very important because we'll need this to log in. Now this file need not be a file actually. It can ideally be stored inside an RFID chip or something like that. But for now it's just a file because it's a prototype. Let's log in with this user. Yes. And yeah, we are logged in, and as you can see, this is the random RSA key and this is the random BigchainDB key that got generated. And no user with this public key registered because we haven't registered yet. So let's go ahead and register. Now registration is just so that it's easy to find this patient on the blockchain. So any lab person or any doctor can just find this patient with a mobile number. So let's do that. MedBlocks register. And done. So this patient is registered on the blockchain. Alright, now we are on the computer of a lab technician who just got the report of the patient. The report is here. So he's got the glucose test, the blood test, and he's also got a chest x-ray. Yes, this lab also has an x-ray machine. So, okay, fine, I just changed the wallpaper. It's not a different computer. So, but yeah, let's see how we can transfer this to the patient. So the first thing that we want to do is first let's create a user for this lab technician. Let's actually cd into this Siddharth's report folder. And let's just do MedBlocks create user. By the way, the create user takes a output flag so that you can just put an O flag and do a lab.json to store that user data. So name of the patient, actually it's not a patient, it's a lab. So let's just call it lab1, I guess. Phone number, let's go with 123456789 0. And it's giving me the warning, and voila, we have the lab.json file. Let's log in quickly. Login lab.json. Yes, and done. We have logged in using the lab.json. Let's just register them on the blockchain too. It's just a 1 second process, and yeah, the lab got registered now. Now what we want to do is we want to send the reports to the patient. So the way we can do that is just using the add command. So as we can see, what the add command actually does is it creates a MedBlock with a file. Now what a MedBlock is the MedBlock exists on the blockchain. Alright, so what it actually is just a reference to an encrypted file on the IPFS and another encrypted key along with it. So it's, to make it simple, it's a way in which people can exchange data without a third party knowing. So I'll just show you how it works. You don't need to know the technicalities behind it. If you want to, you can read my article, which will probably be in the link description. So let's just do MedBlocks add. Let's just look at the help command to see what all it takes. No, not MedBlocks add help. Yeah, so it takes the phone number or an address, and as you remember, we registered the patient on the blockchain with a particular phone number. So this lab technician can send this patient's report just with his mobile number. That's it, nothing else is required. So let's send in the glucose test first. Let's have a look at it. Glucose test, fine, it's just a plain text file. So let's just do MedBlocks add glucose test. Now the thing is, we need to specify to whom it should be sent. So let's do phone, and the phone number was 9944941964. Okay, so that should, oh, by the way, this will probably throw an error because the IPFS daemon is not running. Let's just check. And yeah, the local IPFS daemon is not running. So you have to run Go IPFS or something of that sort. You have to have it installed because obviously MedBlocks uses IPFS in its core. So I just opened another terminal, and let's just run the IPFS daemon. Yes. So that will start the daemon here. Let's switch to our first terminal. Now we can run the same command, and hopefully it should put it on IPFS, encrypt it, and also put it on the blockchain. Done. So a lot of things happened there. Now to break it down, what basically happened was, first it connected to the IPFS local node. Secondly, it encrypted the data and put it on IPFS. Okay, then what it did was, the encryption key itself is encrypted and it's put as a create transaction on BigchainDB. Alright, so it created the MedBlock on the blockchain on BigchainDB. Now the asset was confirmed in block number 13443, and it also got transferred back to the patient. Now all of this may not make any sense to you, and so let's just see how it's used. Now let's see the patient. That's it. Now this file has been put on the blockchain. All right, now anybody can access it if they have the permission. Now we'll talk about what permission means. The lab has sent this report. Let's send another one actually. Let's just, instead of the glucose test, let's also send the chest x-ray. Okay, the same phone number. And yeah, the same thing happened. Now as you can see, this has also been confirmed on the blockchain, and that's it. The lab technician has successfully sent both these to the patient. Now let's see how the patient can fetch this now. Let's also add the blood test report. Let's just take a look at what it looks like. Blood test, that's just ABO. Let's just do MedBlocks add blood test to phone 9944941964. And actually blood test is kind of like an emergency data, so we'll also put in the emergency flag. I'll tell you what it does later. Emergency. Alright, so it will fetch the user data. Okay, fine, that also got sent. Okay, now we are on the patient's computer. The first thing that we need to do, as you remember, we had created a JSON file for the patient first. So first let's log in using that. Yeah, the patient has logged in. Now as you can see, MedBlocks says 3. First it said 0, if you remember correctly. Now let's see, now let's take a look at these MedBlocks. So MedBlocks list, that's the command, and that will list all the MedBlocks that has been added. Now all these 3 were added by the lab technician in the previous the lab technician who added them, and you can see the format as well. The first one is a text file, the second one is a JPEG, and the third one is a text file. So now how does the patient get any of these? Alright, now the thing is, the current user can decrypt, because it was meant for the patient, obviously. So now the patient, all he needs to do is just run MedBlocks get and the ID of the thing. And that will decrypt everything and it will give it as a file here. Now if we open that, we got the same glucose report, and you could do this for any file. So let's just do it for the second MedBlock. Obviously this can be automated to get all files at once. I haven't implemented that. Probably do it today. So yeah, this is a image file, so it looks like a joker for some reason, but let's open it, and yes, we have our x-ray again. Now if you are the smart one, you would be asking me, wait, what about the IPFS hash? Can't everyone on the internet access this? That's right, yes, it's true. Anyone on the internet can access it by just having this IPFS hash. Now let's actually try that for a second. Let's copy this IPFS hash and let's go to our IPFS node. Let's stop that for a second and let's just do IPFS cat that IPFS hash. Now as you can see, nothing is legible. All of this is just random stuff. Like, let's try that for the second one as well, the second MedBlock. IPFS cat of this, and whoa. Yeah, as you can see, it's a big file because this is the image file. So all of this is unreadable by anyone except our user who can decrypt it. So we have encrypted it with a very strong AES key which was generated randomly, and only this user has the permission to decrypt the key. Okay, so now the patient knows, he has this x-ray, the patient has his glucose report, and now he wants to go and see the doctor. Now what does he do? Alright, now we are on the doctor's computer. So the beauty of MedBlocks is that you don't actually need to know anything other than the patient's phone number to get all his medical records. So let's just do a MedBlocks list phone 941964. So now this is the command that's needed to list all the MedBlocks. However, since we are logged in as the doctor now, we cannot decrypt any of these. We know that the patient has some data there. We know that he has a text file here, a JPEG here, another text file here, and that this is also an emergency block. But we cannot access any of it. So now what does the doctor do? Well, he asks the patient to permit. Let's go back to the patient. We are on the computer of the patient now. So let's just list the MedBlocks. And as you can see, this user can decrypt it because we've logged in as our patient now. Now, to permit the doctor, all we need to do is use the permit command. So MedBlocks, let's just look at the help for the permit command. So it takes in a BigchainDB address or the phone. Now from these JSON files, actually no, it's in the doctor thing. So from the doctor JSON, let's just find the phone number. Yeah, that's the phone number. So now the patient in real life would just do this by calling the doctor or something like that. Like he will know his phone number. So let's do MedBlocks permit phone, the doctor's phone number, and following that, let's give permission to, let's say, this JPEG file. Alright, that's the X-ray, and that will write on the blockchain. That's it. Now the doctor has permission to decrypt the file because another key specifically meant for this doctor has been put on the blockchain. Let's go back to the doctor. Alright. Now let's run the same command again. MedBlocks list phone and suddenly MedBlocks 2 can be decrypted by this doctor because the patient just gave permission. Now let's actually go and get that file. MedBlocks get this file. And that's it. That will download that file to the patient. And let's have a look at it. That's the x-ray. Now the doctor has access to that. Now let's say the doctor just wants to make a diagnosis of that. Let's say diagnosis. And let's just put in, you are going to die of cancer. Okay, I know it's pretty morbid, but let's just keep it like that for now. So that's the diagnosis that this doctor wants to make. So to do that, the doctor will just add it as a MedBlock to the patient. That's just very simple. Just add to the phone number of the patient, and let's just add the diagnosis.txt file. Yes. 9944. Yeah, the phone number is wrong. 9944 941964. Okay. And done. Now let's check the thing again. Let's check the. Let's just list all the MedBlocks of the patient. And we can see an extra MedBlock has been added. But notice that even the doctor cannot actually decrypt it unless the patient explicitly gives permission for the doctor. But obviously the doctor can have a local copy of this key, but it's not designed inside of MedBlocks. The doctor can only get permission for a block if the patient, and only if the patient gives him permission to that block. Alright. So now this block can only be decrypted by our patient. Now the patient is eager for his report of what the doctor had to say, and obviously if he just runs the info command, he will know that there is an extra MedBlock that has been added, 4 from 3. So let's just have a look at what the ID of that is. That's the ID. So let's go ahead and use the MedBlocks get command on that. Obviously these file names are getting bigger and bigger. Now let's just you can also output it in a different way. Now the patient can see here itself that you are going to die of cancer is evident. Now we can output it in a different way, like A or something, and it'll just output it to a file which is called A, but obviously this is a text file. This is .txt, and we see you are going to die of cancer. Now the patient is extremely mad at this doctor. He doesn't want any treatment because it's he is also a medical student, and he knows that this is a pretty normal X-ray. What's the reason for the, actually no, it's not a normal X-ray, but yeah, he doesn't believe this doctor, so he wants to go and see another doctor. Now all he has to do is just do MedBlocks permit and the phone number of this new doctor. That's it. And this new doctor will be able to see all his reports. He can do that for any block he wants, and permission is granular. So he can give permission only to the blocks that he wants to give permission to. And otherwise also the doctor can see all the MedBlocks. Like, he will know that there are some things that the patient has not given him permission to, and can request him for more information. But it's up to the patient whether or not to give permission to a particular doctor. Okay, now I talked about the emergency thing. What about that? So what happens if our patient is in an accident and suddenly they are calling us and they are telling, this is the phone number of the patient, we need emergency data. Now this is how we do it. We are already logged in as the emergency account, and we just list all the MedBlocks of the patient. And as we can see, this is an emergency block, and the current user has permission to decrypt because this is the emergency account. So all we need to do is, let's just get that quickly because our patient is dying right now. And okay, our local IPFS daemon is not running. Okay, now we need to get our IPFS daemon running as soon as possible. Where is our go IPFS? Yes, go IPFS. IPFS daemon. Demon spelling is wrong. The emergency is real. DAEMON. Yes. And now let's do the same thing. Okay, so the patient is O positive. Yes, give him O positive blood. So yeah, that's how MedBlock works, and I hope you enjoyed this demonstration.